This is Module 6, Lesson 9. In this lesson, we're going to be using the place value chart and metric measurement to compare decimals. We're going to start with the lesson template for Lesson 9. And we have a couple tape diagrams here. And for the first tape diagram, we're going to look at 67 centimeters. This is a meter. And we know that there's 100 centimeters in a meter. So 67 centimeters would be 67 hundredths of a meter. And we could show that on our tape diagram by coloring in, shading in 6/10. And then we'll divide the next one into tenths, well, into 10 parts, which would be showing hundredths. And we're going to color 7 of those. So we have 67 hundredths of a meter by showing 6 hundredths and 6/10 and 7 hundredths. Then we're going to look at 59 centimeters, which is 59 hundredths of a meter, or in decimal form, 59 hundredths of a meter. And we can show that as 5/10. And then we're going to divide the next tenths into hundredths. And we're going to color in 9 hundredths. Okay, so comparing these two, we see that our first 67 hundredths ends at this point, and 59 hundredths ends at this point. So we can say that 67 hundredths is greater than 59 hundredths. Or in terms of the tape diagram, 57 hundredths of a meter is longer than 59 hundredths of a meter. 67 hundredths is longer than 59 hundredths. In a place value chart, we can show ones. Then this is our decimal place, and tenths and hundredths. So our first number is 0 ones, 6/10, 7 hundredths, and our second number is 0 ones, 5/10, and 9 hundredths. And so our largest place value is the tenths. So 6/10 is greater than 5/10, regardless of how many hundredths there are. We know that 67 hundredths would be greater than 59 hundredths. Let's look at a second one. Here our decimal is 4/10 of a meter. And again, this entire length is 1 meter. So 4/10 would be this much of a meter. Then let's look at a second number, 37 hundredths of a meter. Again, this would be 3/10. And then we'd divide the next tenths into 10 pieces, showing hundredths. We're going to color in 7 of them. So we see that 4/10 of a meter is longer than 37 hundredths of a meter. So even though looking at it as you might with a whole number, you might say, oh, 4 is less than 37. Remember, this is 4/10 and this is 3/10. So 4/10, regardless of how many hundreds there are, 4/10 is always going to be greater than 3/10. So 4/10 of a meter is greater than 37 hundredths of a meter. Then we're going to go on to look at two other types of metric measurement. We looked at length in our first two problems. Here we're going to look at kilograms, which is mass. So we have 4 bags of rice. So here's our weights of our rice. Bag A is 1/10 of a meter, 1/10 of a kilogram. B is 60 hundredths of a kilogram. C is 7/10 of a kilogram. And D is 46 hundredths of a kilogram. And we're going to use the place value chart to write each of these in decimal form. So rice, the bag of rice A has no ones and 1/10. Bag B has no tens, has 6/10 and no hundredths. Bag C has 7/10, and bag D has no hundreds, 4/10, and 6 hundredths. So if we look at this and we want to put these in order, we're going to go from heaviest to lightest. So we're going to start with looking at tenths, since that's the largest of the place values that we have digits in. So we have 1, 6, 7, and 4/10. So the largest value there, the greatest value, is 7. So 7/10 would be the heaviest bag, followed by 60 hundredths, followed by 46 hundredths, followed by 1/10. Because again, looking at the tenths column, 7/10 is going to be greater than 6/10 regardless of what's in the hundredths place. So this would be the order from heaviest to lightest. Then let's look at volume or capacity. And here we have, as in the prior one, we have 4 examples. So we have 4 cylinders. Cylinder A is 3/10 of a liter. Cylinder B is 15 hundredths of a liter. Cylinder C is 29 hundredths of a liter. And cylinder D is 9 hundredths of a liter. So again, we're going to put these in the place value chart in decimal form. So cylinder A, there's no ones, there's 3/10, no hundredths. B is no ones, 1/10, 5 hundredths. C is no ones, 2/10, 9 hundredths. And D is no ones, no tenths, and 9 hundredths. And this time we're going to go least to greatest. So looking again at the tenths column, the least amount of volume would be cylinder D with 0/10. The next would be cylinder B with 15 hundredths. Following that would be cylinder C with 29 hundredths. And finally, the largest capacity would be cylinder A with 3/10. So we can use what we know about metric measurements and our place value chart and our tape diagrams to help us compare decimals. Let's try some problems in our problem set. So for problem number 1, it says express the length of the shaded parts in decimal form. That's the first thing we need to do. Then write a sentence that compares the two lengths. Use the expression shorter than or longer than in your sentence. So pause the video and try A. So first, showing in decimal form, we see that the meter is divided into tenths and 3 of them are shaded. So decimal form would be 3/10 of a meter. The second one, 2/10 are shaded in plus 7/100, so 27/100. We see the first one ends here, the second one ends here. So we would say 3/10 of a meter is longer than 27/100 of a meter. Okay, you try B. For B, we have 3/10 shaded in plus 5/100, so 35/100 of a meter. And for the second one, we have 4/10. And we see that 4/10 is longer than 35/100. But let's write it as a shorter than. So we're going to say 35/100 of a meter is shorter than 4/10 of a meter. Then for C, it says list all 4 lengths from least to greatest. So we're going least to greatest. So look at the 2 measurements at A and 2 measurements at B and put them in order from least to greatest. So least, looking at the tenths, this shortest length would be 27/100 of a meter. The next one would be 3/10 of a meter. Then 35/100 of a meter. And finally, the longest is 4/10 of a meter. And if we look at the 3 lines, we see that in fact, those are ordered in the same way from least to greatest. For 2A, it says to examine the mass of each item as shown on the 1 kilogram scales and put an X over the items that are heavier than the avocado. So take a moment and do that. So the avocados weigh 2/10 of a kilogram. So the apple we see is 12/100, but it's 1/10 and 2/100, so that would be less. The bananas are 6/10 of a kilogram, which is greater than 2/10, so we'll put an X on that one. And the grapes are 61/100, which is 6/10 and 100, which would also be greater than 2/10 of a kilogram. So those, the apples, the banana and grapes would be heavier. Then for B, it says express the mass of each item on the place value chart. So the avocado has no 1s and 2/10. The apple is no 1s, 1/10, 2/100. The bananas are 6/10, and the grapes are 6/10 and 100. Then using this data, answer C. So the avocado is heavier than the apple, since 2/10 is greater mass than 12/100, and the bunch of bananas is lighter than, not by much, but it's lighter than the grapes because 6/10 is less than 61/100. Moving on to number 3, we're going to look at capacity. So it says to record the volume of water in each of the cylinders on the place value chart. So take a moment to do that. So A is no 1s and 6/10. B is no 1s and 3/10. C is no 1 and 9/10. D is no 1s, 9/10, 7/100. E is no 1s, 1/10, and 9/100. And F is no 1s, 4/10, and 8/100. Using the place value chart, now you're going to answer the comparative equations A through C as greater than, less than, or equal to. Take a moment and do that. So for A, 9/10 of a liter is greater than 6/10 of a liter. 48/100 of a liter is less than 6/10 of a liter. And for C, 3/10 of a liter is greater than 19/100 of a liter. Then for D, it says write the volume of water in each graduated cylinder in order from least to greatest. So take a moment to write that out. Looking at the tenths place, the least amount would be 19/100, then 3/10, then 48/100, then 6/10, then 9/10, and the largest amount would be 97/100. And that's the end of lesson 9.